Hello, dear students. Welcome into the fourth lecture on high performance thin layer chromatography. Myself, Mr. M.S. Bale, I am working as an assistant professor at Gokhale Education Society's Arts, Commerce and Science College, Jawar. So, in the previous lecture, we have seen the double beam densitometer and fluorometric detector. That means the last step from the HPTLC operation, that is detection and visualization, we have completed into the previous lecture. So in today's lecture we are going to learn the advantages of the HPTLC and its limitations, and finally the comparison between the ordinary TLC and HPTLC. This part we are going to learn into today's lecture. Advantages of HPTLC. First one will be the no need of internal standard. See, actually in some analysis we are using the internal standard any kind of, but in this HPTLC technique we are not using any kind of internal standard. That is the advantage of the HPTLC. Second one, several analysts can work on the same system simultaneously. That means many chemists or analysts can work on the same system simultaneously. Third one, lower analysis time and less cost. That means time required for the analysis purpose, that will be the very short, and cost of that analysis will be the very less. Fourth application, sample preparation is very simple one, because we are just checking the solubility or miscibility into the solvent, and into that particular solvent we are dissolving the sample. That will be the very easy task. Fifth one will be the choice of solvent, not very critical as it is removed completely. Sixth one, solvent need no prior treatment like filtration and degazing. See, in SPLC we have seen the degazer system for what, to mixing or stirring of the solvent, or we can say removing the any kind of dissolved gases. But in this HPTLC we are not using any kind of filtration or degazer system to remove inner contamination of the solvent. That means there is no any prior treatment of the solvent system, or you can say mobile phase. Seventh advantage, mobile phase consumption per sample is very low. See, only 10 to 15 ml, that much volume of the mobile phase we are using into the separation of the sample component in HPTLC. So there is no big consumption of the solvent. 8 number, no contamination possible as far every analysis, fresh stationary phase and mobile phase are used. See, this is actually the very nice criteria of this HPTSC, because each and every analysis of the sample component here we are using a fresh stationary phase, or we can say the new HPTLC plate and the new mobile phase. So there is no possibility to contaminate the stationary phase as well as the mobile phase. Ninth number advantage, multiple repeated scanning of the same plate at different wavelength is possible. See, suppose a single plate we have used for many samples, that many sample will be separated on a single plate. There is no need to use different type of radiation source or different type of wavelength for the scanning or identify the separated component. This is the main advantage of this HPTLC. Next will be the, sorry, see, these are the actually nine advantages of HPTLC. Rather than this one, there's some other advantages also there. Actually, HPTLC is a cost effective and environmentally friendly as compared to the HPLC, and on a, or you can say, per sample basis, solvent consumption is very less in HPLC. Another advantage will be the sample cleanup is usually simple. Unlike column chromatography, the stationary phase is used only once. And actually, HPTSC is a ideal technique or method because of which is based on different separation mechanism, usually normal phase in TLC, and the densitometric scanning of individual or all fraction can be repeated with the same or different parameters. Since all fractions remains stored on plate, you have many options for evaluating or documenting the fractions both before and after derivatization. So these are all the advantages of HPTLC. Now we will see the limitations of the HPTLC. First limitation will be the cannot be fully automated. See, some part of this HPTLC we can do manually also, so it not fully automated. RF values are not always reproducible, comparatively low resolution, and last one will be the substances sensitive to light and oxygen can create problem. See, some samples that will be the very sensitive to the light, so and oxygen may be present in between this mobile phase, maybe that create a problem while analyzing the sample component or detecting or scanning the separated component. So these are the four limitations of the ESP-TLC. Now we will see the applications of the high performance thin layer chromatography. First one will be the pharmaceutical industry. This is useful in pharmaceutical industry for what? To quality control content, uniformity and purity check. In QC area, the content uniformity we can identify this HPTSC, and to checking the purity, that will be helpful in pharmaceutical industry. Second, in food analysis, that means how much quality of the food that we can check with the help of this HPTSC. Additive pesticide testing, if may any addition in pesticide that we can easily test with the help of this HPTSC technique. Third one, clinical application. In these clinical applications, metabolism study, drug screening, stability, drug screening and stability testing will be done with the help of HPTLC. In forensic lab, it will be used for investigation of poisoning of the glycosides in herbal analysis. Fifth one, it is used in fingerprint analysis. Sixth one will be the identification of the drug in blood sample. Environmental analysis, in that case, pesticides in drinking water, selenium in water, that will be identified with the help of this HPTLC technique. Yet one will be the identification of vitamin C in fruit juice. These are the applications of the HPTLC. Now we are going to see the last part of this HPTLC technique, that is comparison of TLC and HPTLC. See, this is the table of the comparison between TLC and HPTLC part. See the parameter, these are all parameters. This is the TLC part and it will be the HPTLC part. So first parameter, chromatographic plate used. That means what type of chromatographic plate used in TLC and HPTLC. In TLC, handmade or either pre-coated, but in HPTLC only pre-coated HPTLC plate will be used. Okay, this is the difference between TLC and HPTLC. Now the second parameter will be the sorbent layer thickness. That means on TLC plate we are using the sorbent layer below the stationary phase. That thickness will be the, in TLC, 250 micrometer and in HPTLC 100 to 200 micrometer. Now third parameter, particle size range of the TLC plate, or can say stationary phase of the TLC plate, that will be the 5 to 20 micrometer in TLC and 4 to 8 micrometer in HPTLC. Now fourth number criteria, parameter, that will be the pre-washing the plate. Actually pre-washing that will not followed in TLC, but in HPTLC it must be followed. Fifth number parameter, that is application of sample on TLC. Actually the semi-automatic or manually we can do the sample application in TLC, but in HPTLC semi-automatic or either automatic we can use the sample application. Shape parameter, actually shape of the sample on TLC, that will be only spot, not band, only spot, circular spot will be applied on the TLC plate. But in case of HPTLC, according to the our requirement, we can either apply spot or band, circular spot or rectangular band. Then spot size parameter, spot size should be in TLC 2 to 4 mm, but in case of HPTLC 0.5 to 1 mm only the spot size. Sample volume parameter, that will be the 1 to 10 microliter in case of a TLC, but in HPTLC that will be the 0.5 to 5 microliter. See there, this is the very less volume of the sample in case of HPTLC. Number of sample per plate, that means each plate how much sample we can spot. In TLC there is 15 to 20 sample we can spot, but in HPTLC we can use 40 to 50 samples in a single plate. These are the difference point between TLC and HPTLC. Rather than this, the number of sample, sorry, the development or separation time in TLC part, separation time will be the 10 to 15 centimeter, sorry, time, not time, distance. Separation distance will be the 10 to 15 centimeter, and the HPTLC that will be 5 to 7 centimeter. And the development time, actually development time in TLC depends on the mobile phase, and in case of HPTLC 40% less than that of the TLC plate. And reproducibility of the result in case of TLC, that will be very difficult one, but in HPTLC the results reproducibility will be the higher one, or can say easily we are getting reproducible result in case of HPTLC. So these are the difference points between TLC and HPTLC. Here this topic will be completed. Into the next lecture we are going to start the first chapter from this unit number 4, that is solvent extraction. Thank you.